Hello, maybe I have to decide based on this article with the title "The Sign of Novel 60 gigahertz millimeter wave Q short antenna for body-centric communication." Uh, the antenna has the shape like this. We will try to design it, and the antenna use the FR4 substrate and dimension 12.9 millimeters times 14, and the thickness of the substrate 1.6. We try to design it with the CST. We open the CST, and this is the weight and the for the first it is the template, and then microwave antenna next, planar next, time domain next, and this is the dimension millimeter, the frequency in gigahertz. Next, next finish. Front view, and we will model it by click the brick, and then we escape in the keyboard, and we can type this is for the substrate. This is the WS, and this is the LS. We suppose the coordinate in here. This is the 0, 0.0. So the x minimum is minus WS divided by 2 until WS divided by 2, and the y min, we suppose this is the 0 coordinate in y axis. So the y minimum is 0 until LS, and we suppose the coordinate is 0 in here, so the z minimum is 0 until the substrate. And we can choose the material from here, new material. I don't know. We can choose the FR4 from material library, and we can drag this. We find the FR4 lossy, and we can see the epsilon is 4.3, and the electric tangent is 0.025. And then we click preview, and it should enter the value of WS. Maybe we can suppose the WS value is maybe 60. So we can't see in this paper, but we can update it with the parameter list later. And the LS, I think this is the same dimension. I suppose the length of the substrate is 60, and the thickness of the substrate is 1.6 millimeters. And we can okay. We can click this space. This is the substrate. We suppose the coordinate in here is 0.0 in x and y. And then we can make the bidding point in here. Hmm, this is the P, the dimension, and this is the D, and this is the W, and this is the L, and we can make maybe this is the WS. So we can design so the distance from the side one is WS minus W, and we divide by 2. This is the space. We can make the patch first, maybe yes. The patch, maybe from here until here. So we suppose the W is in the patch in the center of the substrate. So the width of the patch is W divided, oh sorry, minus W divided by 2 until W divided by 2. And the Y is W, no, I think the length of this, the distance from the bottom and the distance from the upper is the same. So the first coordinate in here is maybe for S minus L by 2 until S min L divided by 2 plus L, and the thickness of the patch from A substrate until T substrate was A patch. Now we choose the copper, the material, the substrate, the material for the patch is copper analyte with the electric conductivity like this, which is loop, and okay. We suppose the length, the width of the patch is maybe 40. Okay, and L is 30 maybe, or maybe 25. We can change it better. And the T patch or 0.035. Oh, we can edit the dimension like this. OS minus L divided by 2. Yes, maybe in here. And oh, maybe the L is, oh no LS. I think this is L. Okay, I make mistake. Because this is the serum distance. So we can assign the feeding point. The feeding point is x minus from here until here. Here is W divided by 2 minus minus P plus minus D. This is the minimum. This is W divided by 2 minus P and minus D. Uh, and the X maximum for the feeding is W divided by 2 minus P. And the Y minimum is 0 until LS minus L divided by 2. And this is the same for the feeding thickness and the paths. So from A substrate until A substrate plus pH. We suppose the P is 8 maybe, and D is maybe 2. I don't know. We can change it later. Okay. Okay. So for the combination, or this is we can rename it with feeling. And then maybe we can move or shift this feeding by click transform, and maybe this is the X P X feeding field. Okay, I think like that. Review the X feeding field is 0 maybe. Okay. And then we make the circle. In this, we can use the cylinder, click cylinder and click escape from the keyboard, and this big cylinder, maybe big cylinder. Big cylinder has outer radius, big cylinder maybe, in here, inner radius. This is maybe inner in radius big cylinder, and the center is 0.0 until I think this is L as divided by 2. And the step minimum is from this substrate until this substrate plus pH. And this is the material is covered to like the patch. You can preview maybe the diameter. The outer is we can choose 15. I don't know. We can change it, and the inner is maybe 13. Okay. Oh, it's very big. Okay. Just smaller the old radius maybe become 10, and the inner maybe become 9. After we update the parameter list, we should click the home and parametric update. Like this, but I think it's big and become smaller too. The outer maybe 8, and 7. Okay. And I think this is the modeling of the brick with brick and escape slot. The slot has x minimum is 0 until x maximum, I think outer right big cylinder, and the y minimum is for the slot is I think 0 ls divided by 2 minus out right big cylinder until the thickness of the slot. Thickness slot, maybe like that. And this is the substrate until the substrate plus the patch. Okay, like this review. This sort one maybe yeah, like this. Okay. Okay. And we can maybe we can save first. Ini model one. We can add the slot and the big cylinder become one. This is maybe the big cylinder can be Boolean operation add with the slot like this. Now, we can remove or shift move. I mean move. We can shift it X slot and Y slot. We can change 0. And this is 0 maybe. Okay. And maybe we can also can rotate it. Rotation angle in the Z axis. Rotate slot like this. Preview 0. Okay, and then we can subtract the paths to the big cylinder. We can see like this now, and we can add the paths and the building. And then we can make the ground plane like this. This is the thickness of the ground plane. And this is like this from minus WS divided by 2 until WS divided by 2, and the Y minimum for the ground is from 0 until Maybe I think this is the maybe from the LS, the pi by 2 minus L divided by 2 from here. Oh, y minimum from 0 and the y maximum until this. And maybe we can make a little of the space minus maybe grown space like this. And the thickness of the ground from minus the patch until 0 like this. We preview and we can like this. Now we can see, okay, the gas is the ground plane space like this. There is a space between the patch and the ground plane. We can see maybe it can make the wider of the band. I think it's finished for the design. We can make the, oh, it has a small of the dimension, so we can change it by variation this parameter list by varying the parameter list. Okay, now we can make the feeding point like this. With the zoom like this. This is the feeding. We can click add and we can choose this point and we click double click and then in the home and macros and then solver port calculate coefficient like this construct calculate close like this. This is the port. Okay, the set view fonts views. Now we can make the field monitor. We can simulate it maybe from the frequency. You can tapping from here, maybe from 2 until 6 gigahertz. Okay, and we can. This is the field monitor. We can. This is our field from 2, 3, 4, 5, and this is the 6. Okay, and maybe the H wheel we can adjust from 2, 3, 4, 5, 6. For the E wheel, 2, 3, 4, 5, 6. Okay, we can see the wheel monitor will be displayed like this. And we can run it and we can see what happened for the, we choose the normalist to click impedance in 50 ohms and click start. You can see the result of the 1D parameter, 2D and the far field performance. Thank you.